Hello everyone, welcome back to the channel. Today I'll be starting a new series where I'll be learning Kubernetes live with you, and I'm very excited about it. Does not mean that I am going to do away with the flight booking engine series. I'll be doing that also in the evening. So every morning I'll be studying Kubernetes, and I invite you to learn together with me. And then every other evening, I'll make sure that we continue with building the flight booking engine. So I want to learn Kubernetes that I can later use in my career or in that project or other side projects when necessary. So let's get started with it. The first thing I'll do is to go to documentation. I want to follow along with the documentation. And then we see this part which says understand Kubernetes. Then I'll go to why Kubernetes. I'm a big fan of learning using the documentation. I'm a big believer in it, and that it's still one of the best ways to learn anything on the internet. And of course, later on, once I've grasped the fundamentals, I can easily shift them to anything and be able to quicken anything using artificial intelligence. But at the very core, I need to understand things so that when AI does something wrong or something right, I am able to discern that this is right and this is wrong and do things better as necessary. So join me and let's start this. So it says overview. Okay, it says Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitate both declarative configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes services, support, and tools are widely available. And I love the fact that Kubernetes is declarative, okay? Because this tells me that we shall tell Kubernetes, uh, using the configuration, we shall tell Kubernetes what we need to happen, okay? The result of what we need to happen instead of the processes. So instead of saying do a step 1, 2, 3, 4, we simply say we need this, okay? Produce this, and to go through all the steps to do that for us. It says this page is an overview of Kubernetes. It says the name Kubernetes originates from Greek, meaning helmsman or pilot. Then they say K8 as an abbreviation results from counting the 8 letters between the K and the S. So if you look at this word Kubernetes, if I start counting from the U, it will be 1, 2, the B is the second, the third, the fourth, the fifth, the sixth, the seventh, and the eighth. So those are 8. Okay, so that's now the 8 in this abbreviation. Then the K is the first K at the beginning, okay, with the word Kubernetes, and the S is the last letter. So that brings about K8. So they're saying K8 as an abbreviation results from counting the 8 letters between the K and the S. And they're saying Google open sourced the Kubernetes project in 2014. This is good news. And it goes ahead to show the power of open source and how open source can help us widely. Okay. So let's go on to say and read them in. It says Kubernetes combines over 15 years of Google's experience running production workloads at scale with the best of breed ideas and practices from the community. Just before we continue, I would suggest that you try to write some notes. Okay, there's a power about writing notes. You can use online note takers or other tools. Okay, personally, I use a book. Okay, and I have a book right here. I don't know if you can see it. Okay, but I'm going to be writing. I have a book here and I have a pen. Okay, pretty basic, pretty simple. And I'll be taking notes from time to time. In fact, even after this stream, I'll make sure I summarize what I've learned, and I'll make sure I decide to understand. So make sure you do the same. Writing has a power, a secret power that people do not understand yet. All right, so let's go on. It says why you need Kubernetes and what it can do. Documentation says containers are a good way to bundle and run your applications. In a production environment, you need to manage the containers that run the applications and ensure that there is no downtime. So if you don't know what a container is, it is simply an easier way of wrapping up your application code and its dependencies. Okay, one of the one of the best ways of doing containerization or working with containers is a tool called Docker. Okay, so if you do not Docker, please go to the channel, look at the playlist, and look at a playlist called "Building a Fast API Building a Flight Booking Engine." Okay, end to end using Fast API and Next.js. In that series, there's a video where I talk about virtualization and containerization. Okay, but let's go on and read this. Okay, you can also study about containerization online using Docker, and it's important to know Docker and containerization before you get to Kubernetes. So I would suggest that you first learn that. Then here they say, for example, if a container goes down, another container needs to start. Wouldn't it be easier if this behavior was handled by a system? Yeah, this is cool because if you're using only, for example, only Docker as your containerization solution, if your container went down, okay, there is no, you have to manually start that container. Okay, that is how Docker containers work. Once a container Docker, when a Docker container goes down, you have to manually start it, and that of course causes downtime. Okay, but here they're saying if I need to manage the containers that run the applications and ensure that there's no downtime, then Kubernetes is a good way to do that. Okay, it could be easier for us because they're trying to imply that it is easier if when your container goes down, it is restarted automatically instead of manual restarts. And they're saying that's how Kubernetes comes to the rescue. Okay, they're saying Kubernetes provides you with a framework to run distributed systems resiliently. It takes care of scaling and failover for your application, provides deployment patterns, and more. This is very good. I'll just read it again to make sure I've digested it in my mind. They're saying that's how Kubernetes comes to the rescue. Kubernetes provides you with a framework to run distributed systems resiliently. It takes care of scaling and failover for your application, provides deployment patterns, and more. They're saying, for example, Kubernetes can easily manage a canary deployment for your system. So, what I understand from this is that when a container goes down, Kubernetes is able to understand that a container has gone down and it will restart it for us, okay, to ensure that the downtime is not bad, okay? And this is very good. And when I see the scaling, this makes me know that in case my application is maybe suddenly gets maybe lots of requests, okay, Kubernetes is able to increase the number of containers, okay? So that's what I understand from this, okay? And again, if you have a different thought and what I'm saying is probably not clear, go ahead, of course, and comment about it in the chat and let me know. So they're saying Kubernetes provides you with, the first thing here I'm seeing is service discovery and load balancing. Now, of course, if you're a developer, okay, and you have not learned about uh, service discovery and load balancing before, this could be quite maybe new and fresh to you. But many backend developers, I'm sure, have an idea about what service discovery is and load balancing. But of course, if you do not know that, we are going to learn about it in this series, okay? But I'm very happy to know that Kubernetes provides service discovery and load balancing. So let's read. They're saying service discovery and load balancing, Kubernetes can expose a container using a DNS name or using their own IP address. That's very good. So if I have like 10 containers, okay, I'm I'm assured that there's an IP address connected to a container and a DNS name connected to a container. Now they're saying if traffic to a container is high, Kubernetes is able to load balance and distribute the network traffic so that the deployment is stable. This is actually load balancing. Load balancing is simply distributing the load, because if the load and traffic only goes to one container, the resources of that one container may not be able to keep that container alive. Okay, so the container would crash, causing downtime. Okay, so instead of, let us say, if the capacity of one container is 10 requests, okay, per second, and suddenly we have 20 requests per second, instead of overloading that one container, which will fail because of overload, Kubernetes will give the requests to another container to share. So if you have two containers, you have one taking 10 requests and another having 10 requests, because you have 20 requests and one container can only have at most, maybe I can illustrate this using a drawing. There's a tool called TL Draw that I love using for illustrations and these kind of things. So I'm going to get it open. Okay, it looks to be taking some time. Okay, there's a bunch of stuff I was using here, doing here. Let me try to eliminate all of them. Okay, so this is what they're saying. Okay, we have requests. Okay, let's say this is, let me get the pencil tool. We have the first request. Okay, I'll say R for to mean requests. Okay, well, let me just write the full word. So we have a number of requests. I like doing this to make sure I've understood. So we have, this is another request. This is another request. Okay, and here is the Kubernetes system. Okay, so I'll say K8, and now we now know what K8 actually means. So we have the Kubernetes system. So you're saying if we have, let's say, about 3 containers here. Okay, these are containers, and every container can handle at most 1 request. Okay, meaning if this request goes to this container and this other request goes to this container will fail, okay, and crash. So instead of this happening, they're saying that Kubernetes will send the first request to container, let's call this container A, okay. Then the next request maybe can go to container, can call it container B, okay. Then the next request will go to container C, okay. Of course, the strategy for doing this depends, okay? And if you have some experience, you can know about the load balancing techniques, okay? But I'm sure in this series, we're going to learn about them. So this is what load balancing is all about: sharing the traffic between a number of containers, okay? Actually, if you have only Docker, you'd hustle doing this. For those who know Docker, okay? You'd hustle if you try to achieve this. So this is how I understand it, okay? If you think it's different, please let me know in the chat. Like, I'm learning for the first time, and yeah, I am open to learning and unlearning. Okay, so this part explains what they call load balancing, but this other first part explains what is called service discovery. Okay, for service to be, what I understand by this is that Kubernetes can we can have, with Kubernetes we can have a service. Okay, a service sitting ahead of everything. Okay, let me draw this better. You can have a service sitting ahead of everything. Okay, a logical tool, okay, or a logical layer, which will help us expose our containers, okay, to the users. Okay, so this one we can give it a name. Okay, maybe we can call it maybe payment. Okay, can call it a payment service. Okay, for the container running in at A. Okay, can call this probably like an orders service if this was an e-commerce app. Orders service, okay, and this can be probably something else. Okay, maybe a booking service. That's the whole gist of it. Okay, having names that can easily be discovered by the external world. Okay, because you do not want your the external world suffering to remember certain complex IP addresses which could change. Okay, let us say, like, for example, if the payment container was up, okay, and its IP address is like 1.2.3.4, okay. Later, when this payment service dies, okay, it can be changed to something maybe like 1.3 point. So this is not an accurate IP address. I'm just illustrating 1.2.5. like that. Okay, this changes everything. Okay, and you don't want the external world to suffer figuring out what's the new IP address. Okay, and another thing is that even as we don't want to constantly keep changing the configuration, okay, of the IP address, it will be a lot of work, especially if you have like hundreds of containers running. Okay, and then maybe suddenly 100 of them failed and they were recovered, but the IP addresses have changed. Tracking all of them can be a lot of hard work. So what happens is that we can have a service, okay, that is responsible for knowing which containers and which IP addresses have changed, and we simply track them using a name rather than an IP address. So tracking using a name would be good. So under the hood, even if the IP address changes from maybe 2.4.6.7, all this one still maps to this service name. If let it change maybe to 1.2.3.6, okay, all this still maps to the payment name. Okay, or we can have only one DNS, okay, one IP address to represent all this, okay, to represent all these changes. That is the advantage of service discovery, and I actually like it. So that's how I understand this. Now they're saying storage orchestration. They're saying Kubernetes allows you to automatically mount a storage system of your choice, such as local storages, public cloud providers, and more. When I go ahead here, they're saying automated rollouts and rollbacks. I think this makes sense. Storage orchestration. I think probably 90% of applications in the world need storage. Okay, so yeah, make sure you understand this. Okay, simply storing things either locally or in the cloud. So let's go to the next point. It says automated rollouts and rollbacks. You can describe the desired state for your deployed containers using Kubernetes, and it can change the actual state to the desired state at a controlled rate. For example, you can automate Kubernetes to create new containers for your deployment, remove existing containers, and adopt all their resources to the new containers. This is good to know, okay? Whereby I can say, okay, I don't want this, but I want this other one instead. And I can go back to something which was working, okay, to a previous state which was working very well, or I can make my containers adopt to new stuff. This is good to know. So I'll go ahead. They say automatic bin packing. They're saying you you provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. You tell Kubernetes how much CPU and memory, which is RAM, each container needs. Kubernetes can fit containers on your nodes to make the best use of your resources. So I want to read this again. You provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. Okay. So what I'm understanding from this is that a group of nodes, which I'm guessing are simply machines, virtual computers, or simply computers, are the ones responsible for running containerized tasks. And this makes sense because, for example, my laptop is a machine, okay, can be a node, and inside it, it's running a container, okay. So let us say you tell Kubernetes how much CPU and RAM each container needs, okay. For example, maybe a container needs maybe an M1 computer or Ubuntu 20, okay, and RAM of probably 30 GB, okay. And then they're saying Kubernetes can fit containers onto your nodes to make the best use of your resources. So yeah, this is what automatic bin packing is all about. Yeah, I think I understand this, okay? But having this name here being called automatic bin packing is a relatively new term to me, okay? So far we have service discovery and load balancing, we have storage orchestration, we have automated rollouts and rollbacks, and automatic bin packing. Okay. Then you have something called self-healing. Let's read about this. They're saying Kubernetes restarts containers that fail. Okay, and actually they explained this earlier. Okay, replaces containers, kills containers that don't respond to your user-defined health check, and doesn't advertise them to clients until they are ready to serve. So if a container is not meeting requirements, containers won't know what is dirty. Okay, so what I'm understanding here is that Kubernetes will sweep all the rubbish under the carpet for some time, okay, and then solve all the issues and then expose the stuff to our clients. This is very, very good self-healing because trust me, in case I had many, let's say over maybe 100 containers or thousands of containers running, I wouldn't want to manually, maybe even run a script to restart them. That would be crazy, okay? So yeah, this is very good. Let's go to the next one. They're saying secret and configuration management. They're saying Kubernetes lets you store and manage sensitive information such as passwords, OAuth tokens, and SSH keys. You can deploy and update secrets and application configuration without rebuilding your container images and without exposing secrets in your stack configuration. So I'll read this again. Sometimes you need to read something again to make sure you've understood it. Kubernetes lets you store and manage sensitive information such as passwords, auth tokens, and SSH keys. You can deploy and update secrets and application configuration without rebuilding your container images and without exposing secrets in your stack configuration. Okay. So yeah, this is good. Also good to know. Very important. All right. So I'll move on to this. Okay. Ideally, Kubernetes helps us to, in a safe and secure way, okay, manage our secrets. Okay. And when the secrets maybe change, the containers are simply rebuilt so that they pick the current state of the secrets, okay, without exposing the secrets, okay? Because if they're exposed, of course, that's a huge risk, okay? And that shouldn't happen ideally. Then after that, I will go ahead to read the next one. Says batch execution. They're saying, in addition to services, Kubernetes can manage your batch and CI workloads, replacing containers that fail if desired. Okay, interesting. I'll go to the next one. Says horizontal scaling. Scale your application up and down with a simple command and with a UI or automatically based on CPU usage. Okay, so if the load increases, we can scale up. If the load and the traffic reduces, we can scale down. So you're saying IP version 5, version 6 dual stack. Saying allocation of IP version 4 and IP version 6 addresses to pods and services. Excuse me, I have a bit of a cold and flu. All right, let's go on. So they say designed for extensibility. Add features to your Kubernetes cluster without changing upstream source code. Okay. This also makes sense. I'll read it again just to make sure I've got it. Add features to your Kubernetes cluster without changing upstream source code. Okay. So we can make changes to the cluster without actually pushing code. Okay, that's interesting. Okay. And of course, this previous one is simply IP version management. If you don't know about IP version, IPs and their versions, you can do some search on YouTube and you'll see videos and tutorials on networking. Okay. Okay. So the first part was the overview. They've explained to us why we need Kubernetes and what it can do. And off the top of my head, I now know that it helps with self-healing, okay? It can help us automate rollbacks, okay, and rollouts. It can help us with service discovery and load balancing. It can help us with IP allocation, okay, horizontal scaling, batch execution, secret and configuration management. And of course, you don't have to memorize all this by heart. Okay, you can even mention this, I think, in an interview. Okay, how you understand it rather than having the textbook cramming. Okay, like for example, if instead of saying storage orchestration, I can tell someone that Kubernetes helps us to automatically handle and mount storage. Okay, which could be local storage or public storage. Okay, so the understanding is much better. So I'll go on to the next part, which says what Kubernetes is not. So it's saying Kubernetes is not a traditional, all-inclusive PaaS platform as a service platform. Now they're saying since Kubernetes operates, I need to select this whole part and read it at a go. They're saying since Kubernetes operates at the container level rather than at the hardware level, it provides some generally applicable features common to PaaS offerings, such as deployment, scaling, load balancing, and lets users integrate their logging, monitoring, and alerting solutions. So it has some platform as a service offerings like deployment, load balancing, scaling, etc. But it's not a platform as a service, but it offers some features of a platform as a service. So you're saying, however, Kubernetes is not monolithic, and these default solutions are optional and pluggable. They're saying Kubernetes provides the building blocks for building developer platforms, but preserves user choice and flexibility where it is important. Okay, so it has already, I think, by building blocks. I'm sure they have made up a few setups and components of configuration, which make our work easy. Okay, but we can change them. Okay, according to our business needs. So I think Kubernetes does not limit the types of applications supported. Kubernetes aims to support an extremely diverse variety of workloads, including stateless, stateful, and data processing workloads. Okay. If an application can run in a container, it should run great on Kubernetes. Kubernetes does not deploy source code and does not build your application. Continuous integration, delivery, and deployment CI/CD workflows are determined by organization cultures and preferences as well as technical requirements. So Kubernetes is not responsible for deploying our source code and does not build our application. This, I think, was a misconception in my mind. So I think now I understand it even better. We go on to read the saying, Kubernetes does not provide application level services, such as middleware, for example, message buses, data processing frameworks, for example, Spark, databases, for example, MySQL, caches, no cluster storage systems, for example, Ceph, as built-in services. They're saying such components can run on Kubernetes and or can be accessed by applications running on Kubernetes through portable mechanisms such as the Open Service Broker. Okay, so application level services are not handled or provided by Kubernetes. Okay, they're saying Kubernetes does not dictate logging, monitoring, or alerting solutions. It provides some integrations as proof of concept and mechanisms to collect and export metrics. Okay, so we can get logging, monitoring, and alerting using integrations, but out of the box, it does not do that. Then it says Kubernetes does not provide or mandate a configuration language or system, for example, JSONnet. It provides a declarative API that may be targeted by arbitrary forms of declarative specifications. You're saying Kubernetes does not provide nor adopt any comprehensive machine configuration, maintenance, management, or self-healing systems. So they're saying, additionally, Kubernetes is not a mere orchestration system. In fact, it eliminates the need for orchestration. The technical definition of orchestration, the technical definition of orchestration is execution of a defined workflow. first do A, then B, then C. Okay. In contrast, Kubernetes comprises of a set of independent, composable control processes that continuously drive the current state towards the desired state. It shouldn't matter how you get from A to C. Centralized control is also not required. This results in a system that is easier to use, more powerful, robust, resilient, and extensible. So this explanation, what I've just read from actually this part, okay, to here, is simply explaining to us what being declarative is all about. Okay, so we can see here a bit of historic context for Kubernetes. Now they're saying, let's take a look at why Kubernetes is so useful, why by going back in time. Okay, so here I see traditional deployment, I see virtualized deployment and container deployment. It's actually very important to know this. Okay, so let's get on with it. So with the traditional deployment, I'm seeing that we have apps, an app layer, operating system and hardware. With the virtualized deployment, I'm seeing apps on top of virtual machines, okay, which have the binaries and libraries and the operating system. Then we have the hypervisor, operating system and hardware, okay. Then you have the container deployment where we have the apps, okay, running in containers, and they have some system files in the bin/library. Then the container runtime, operating system, and hardware. So I guess down here they have the explanations for each. So let's look at one by one. So traditional deployment era. They're saying early on, organizations, and this is very important to understand. Early on, organizations ran applications on physical servers. There was no way to define resource boundaries for applications in a physical server, and this caused resource allocation issues. For example, I'm going to read this. For example, if multiple applications run on a physical server, there can be instances where one application would take up most of the resources. And let me read this again. For example, if multiple applications run on a physical server, there can be instances where one application would take up most of the resources. And as a result, the other applications would underperform. Okay? One application takes up all the resources and other applications underperform because one guy has taken up everything. A solution for this would be to run each application on a physical server. Okay. So that one application does not consume the resources of another. So by running each application on a different physical server, you solve that issue. Now they're saying, but this did not scale as resources were underutilized, and it was expensive for organizations to maintain many physical servers. Yeah, this is definitely very expensive. Imagine you had 100 applications. That would mean 100 physical servers. Each needed their own resources. Yeah, very expensive. Yeah, so the traditional deployment era whereby you have your applications sitting on operating systems and a hardware, physical hardware was very expensive. So next up, we're going to the virtualized deployment. So the virtualized deployment era is explained. It says as a solution, virtualization was introduced. It allows you to run multiple virtual machines on a single physical server's CPU. They're saying virtualization allows applications to be isolated between virtual machines and provides a level of security as the information of one application cannot be freely accessed by another application. I'll read this again. So virtualization, it was a solution to the traditional deployment. So I'm guessing it should be solving this part of being expensive for organization. Let's read this again. It's saying as a solution, virtualization was introduced. It allows you to run multiple virtual machines, VMs, on a single physical server CPU. Virtualization allows applications to be isolated between VMs and provides a level of security as the information of one application cannot be freely accessed by another application. They're saying virtualization allows better utilization of resources in a physical server and allows better scalability because an application can be added or updated easily, reduces hardware costs, and much more. Okay. Yeah, this is actually the real advantage, because you want the money, okay, to be less. Okay, instead of burning a lot of physical servers, you can run multiple virtual machines on one physical server and share the single server's CPU. So the same with virtualization, you can present a set of physical resources as a cluster of disposable virtual machines. So you have one physical server, okay, but then you have a cluster or a group of machines, okay, but they are virtual. Why are they virtual? Because they are all running logically on a physical machine. Now they're saying each VM is a full machine running all the components, including its own operating system on top of virtualized software, meaning on top of the virtualized hardware. So if this is hard for you to understand, I can easily draw it for you, okay? So it's the traditional way is like so, okay? You have an app, okay? An application, which simply requires hardware, okay? So this requires your hardware, and then down we have the operating system, okay? But this is physical. For virtualization, what happens is that you have multiple apps, okay? You have isolated machines, okay? So this could be a Windows machine, okay? This could be a Windows machine. This could be a maybe a Mac machine, okay? With Mac OS, okay? Then here you have a software which helps you to do the virtualization, okay? Like we see in the image, it's called the hypervisor. We have the hypervisor. Then here we have the actual physical hardware, okay? The It is supposed to be OS first, okay? Then we have the hardware, okay? Down here. That's the way it works. So ideally, okay, even here, this I'm supposed to hardware is supposed to be down, okay, to represent it correctly, because the hardware is the OS is supposed to sit on the hardware. Let me edit it. So I'll copy this tool, try to copy all this. So I'll drag this here, select this, cut it, paste it up, and drag it there. Okay. So this is the correct way to represent it. I'm trying to group all this hardware stuff together, but it seems not to move. Okay. But ideally, like you see, so hardware, come here, group this. I like this TL draw. Sometimes can make writing easy. Yeah. So the operating system sits on top of the hardware. So that's how virtualization is. Okay. You have an actual virtual machines. Okay. So this Windows machine has its own resources. Okay. That are shared. Okay. So it shares this. It shares the CPU. Okay. It shares the CPU. Okay. Of this physical machine. Okay. But right here, the operating system is different. Like after this is Windows, this is Mac OS, okay, running on, for example, maybe a Ubuntu. This could be like a Ubuntu physical machine, okay, a Linux, okay, a Linux machine, and that is how exactly virtualization works, okay. You have the physical machine, which is a Linux machine, but on top of it, you have Windows, Mac OS, one other version of Linux or Ubuntu distribution running on this physical machine. And this happens through a tool called a hypervisor. Okay, so that's what they're trying to say here, that each VM is a full machine running all the components, including its own operating system on top of the virtualized hardware. And you can see that the image here has the same thing. Okay, we have apps running in the virtual machines. Okay, And through the hypervisor, they interact with the operating system and the hardware of the physical machine. So we can go ahead to understand this. It's saying container deployment error. So we have known about the traditional deployment, virtualized deployment, and container deployment. My mentor in DevOps actually says this is a popular interview question, okay? Having to understand what traditional deployment is, virtualization, and container deployment. It's a common question. So I'll go ahead. Where is this part? So containers. They're saying containers are similar to virtual machines, but they have relaxed isolation properties to share the operating system among the applications. Okay? Containers are similar to virtual machines, but they have relaxed isolation properties to share the operating system among the applications. Therefore, containers are considered lightweight. Why are containers lightweight? Because they have relaxed isolation properties. Okay, they don't have the entire uh, operating system and application libraries and everything. Okay, like a virtual machine has. Remember, a virtual machine is a full computer. Okay, a full computer with all components. Okay, a container doesn't have all the components. So because a container lacks all the components, it makes it lighter. Okay, so it becomes lightweight. So they're saying similar to a VM, a container has its own file system, share of CPU, memory, process space, and more. Okay, so there are some similarities that a virtual machine has a file system, a container has a file system too. It has a share of CPU. Okay, virtual machine has some memory, container also has some memory. A container has process space, virtual machine also has process space. They're saying as they are decoupled from the underlying infrastructure, they are portable across clouds and OS distributions. Okay. So remember, a virtual machine is coupled to the underlying architecture of the machine, but a container is not. Okay. Which means you can put it on any cloud platform and any operating system distribution and it will work very well. This is what I understand from this. Then I'll go ahead to read. They say containers have become popular because they provide extra benefits such as agile application creation and deployment. They're saying increased ease and efficiency of container image creation compared to VM image use. If you want to try out creating virtual machine VMs, look out for a tool called VirtualBox. I used to play around with VirtualBox and actually I would use it for one of my courses when I was studying. Okay, to do virtualization, install I think VirtualBox and try to work with it. Okay, and try to do virtualization. You discover that installing it, okay, creating images. Okay, so the virtualized to get those virtualized machines on your computer, you need what they call a VM image, a virtual machine image. Okay. Like for example, if my physical machine is a Mac OS and I want to run Windows and Linux on my Mac, okay, I would have to, using VirtualBox, I would have to get a VM image for Windows and a VM image for Linux. That is how it works. Okay. But creating them, okay, is not easy. Okay, it's actually much easier. So to actually experience it, download VirtualBox and get an image. Okay, and you'll see that creating and deploying a VM is not as easy. Okay, as it sounds. Okay, but containers are way easier. Okay, to start to create and literally play around with them. Okay, left, right, and center. So they're saying continuous development, integration, and deployment. So they're explaining that this is why containers have become popular. And they're saying provides for reliable and frequent container image build and deployment with quick and efficient rollbacks due to image immutability. Okay, so images are immutable, and this helps to quickly build and deploy them with quick and efficient rollbacks. Very good. Okay. Then, but now remember, our containers will be running within Kubernetes. Let's go on. They're saying dev and ops separation of concerns. They're saying create application container images at build or release time rather than deployment time, thereby decoupling applications from infrastructure. Yeah, this is good. It's better to create your containers at the build time or release time, okay? That is a separate stage, okay? Then later you can decide to deploy. Another benefit of and reason why containers became more popular is observability. And they're saying not only surfaces OS level information and metrics, but also application health and other signals. Because you need to know how is your application doing, okay? The resources enough, okay? Are they becoming fewer? Do I need to scale up something? I'll go on. They're saying environmental consistency across development, testing, and production. Says runs the same on a laptop as it does in the cloud. Okay. And if you've been watching my series, and better I have a flight booking series that I'm working on right now. Okay. Maybe I can quickly show you. And then in this project, I deployed to AWS. I want to go to it. So if you watch this playlist, at some point I was able to deploy to AWS using, I think this video should be around here, automate AWS infra with GitHub Actions. Okay. I deployed a container to AWS EC2. I think this and these two here. Okay. And it was so easy. And so actually from here, 1, 2, 3, 4, these videos deal with that. Okay. And later I'm going to integrate uh, Kubernetes with this project. Okay, so please watch this. Okay, watch every video here and you learn a lot. Okay, this is an end-to-end project that I'm building with Fast API Next.js, and I'll deal with the DevOps, do AI integrations, and so on. Okay, so let's go back and get done with this. So this is good. Way back, in fact, it's a popular thing even up to now that when you tell a developer that maybe the application is not working, they quickly tell you that it's working on their machine. Okay, not knowing that their machine is different from yours. Okay, it could be because of maybe different dependencies, different operating systems, different environments. Okay, so your containers uh, remove this. As long as you have your application containerized, it will work easily in the cloud, like on your laptop. And like if you watch these videos here where I automate deployment to AWS EC2, okay, using Docker, you'll find that how it worked exactly on my machine happened in the cloud, okay, effortlessly. So we have cloud and OS distribution compatibility. Says it runs on Ubuntu, RHEL, Core OS, on premises, on major public clouds, and anywhere else. Application centric management raises the level of abstraction from running an OS on virtual hardware to running an application on an OS using logical resources. I need to read this again. Raises the level of abstraction from running an OS on virtual hardware to running an application on an OS using logical resources. Okay, I get it. It says loosely coupled, distributed, elastic, liberated microservices. Applications are broken into smaller independent pieces and can be deployed and managed dynamically. Not a monolithic stack running on a big single purpose machine. Yeah. Of course, if you have one big single purpose machine, this could be a single point of failure. Once that machine goes down, it's game over for you and your business. Okay. But then if we have applications which are broken down into smaller independent pieces and can be deployed and managed dynamically, then that gives us actually redundancy, which is good. Okay. It helps us achieve fail tolerance. And then we have what they call resource isolation. They say predictable application performance, which is good. You want to know what your application can do and what it cannot do very easily. And says resource utilization, says high efficiency and density. Okay. Now they're saying what's next. Okay, but maybe just talk about this. Okay, because with a virtual machine, I'm assuming maybe you had like 50 GB of RAM. Okay, if you try to use a VM like I've told you, you'll quickly discover that VM images, okay, are very big and heavy. Okay, trust me, it's in gigabytes. Okay, it's in gigabytes. But in containers, it's actually small. You can run a container and you're consuming only like 50 MB. Okay, even 100 MB or 30 MB. Okay, is what they call multi-stage container builds, which can help you even achieve very small MBs. Okay, so with containers you can have just MBs consumed, but with VMs it's really heavy because you have a full machine. Now imagine having several full machines. Okay, so if one machine had like required like maybe 100 GB or 10 GB, let's say 10 GB, and you have 100 application instances that you need. Okay, that would mean 10 GB times 100, that's a lot, 1000 GB. Okay, but similarly, you can have a similar setup whereby in a container you need maybe only 10 MB. Okay, and if you multiply 10 MB times 100, that's only 1000 MB. Okay, less and way efficient. Okay, so tomorrow in the morning I'm going to study Kubernetes components. Okay, and like I've told you, this is my first time learning Kubernetes, and I love learning using documentation. Later, when I've understood things, I can automate them using AI. Okay, but remember, AI has been trained on wrong and correct things, just like Stack Overflow. Okay, so with this, I'm sure I'll be able to, even you as you learn along with me, you'll be able to understand things and know them at a very deep level. So make sure you take notes. Okay, this today in the evening, I'm going to be continuing the building of the flight booking engine. And today I'll be actually integrating the Next.js frontend to the Fast API backend. So don't miss that. Okay. So every morning I'll be studying Kubernetes. Evening I'll be continuing the project. And of course, if you're watching this for the first time, simply check out the playlist on this channel, and you'll find out that yeah, we've moved a long way. About 2 months now, building a project. But every morning will be for learning this. So this is just to make sure that all those who have been building with me this project, okay, do not get confused and say, oh, why abandoning our project and you're going to learn Kubernetes? No. Later, of course, we shall use Kubernetes in this project. All right. Thank you for learning with me. Meet you tomorrow at the same time, and let's learn about the Kubernetes components. See you in the next stream. Bye for now.